Welcome to Murano number 7. Heartless machine with sensing and decision-making using similar energy flow. In the previous video, we talked about Plato's idea from a quantum mechanical point of view of creative evolution that synthesizes the properties of substance using the basic forms of properties and the selective interaction of basic matter in connection. As a side effect, we found out that Plato's basic elements are not basic forms. This video takes a closer look at materials like microchips in order to better understand what considered events as unique energy flow states through the connections of individual rhizome atoms. We will expand the concept of interconnection of energy waves. Both Whitehead and Deleuze emphasized the importance of events or actual occasions in understanding the nature of reality. Both saw the world as a constantly evolving and dynamic process, in which events or actual occasions are constantly interacting and forming new structures and relationships with one another. For Whitehead, actual occasions are the fundamental units of reality that make up the world we experience. As we have discussed, experiences can create energy streams that connect various abstract higher-order vectors of forces in the mind. Deleuze also saw that the world is composed of a vast array of events with multiplicity that each have their own multiple identities and ways of beings and interact with each other to form more complex structures and processes. Whitehead saw atoms as complex structures that are themselves composed of actual occasions, which interact with one another to form more complex structures and processes. This interaction is called prehension, the process by which a real-world situation incorporates aspects of other real-world situations into itself. It's a vector composition. Whereas Whitehead emphasized the importance of process and creative development, Deleuze focused on difference and the constantly diverse, connecting, becoming, evolving nature of beings. This process was guided by what Whitehead called creative advance, which he saw as a kind of cosmic creativity that was always pushing the universe towards new and more complex forms of existence. In quantum mechanics, superposition refers to the idea that a particle can exist in multiple states at the same time, and, as we discussed in the previous video, combine the two to create completely different entities in a creative evolution. For example, an electron can exist in two different energy levels simultaneously. This is in contrast to classical mechanics, where particles are assumed to exist in a single state at any given time. When two or more particles are in a superposition state, they can become entangled with one another. Entanglement is a phenomenon in which the properties of one particle are dependent on the properties of another particle, even when the particles are separated by large distances. Selection and connection among superposition states can occur through a process known as measurement or observation. As mentioned in the previous video, when a measurement, observation, relationship, connection, wave synthesis, is made on a particle, the superposition state of the particle is unified, thus strengthening the particle nature, weakening multiplicity and superposition and enhancing particularity. The act of measurement forces the particle to choose a single state out of the multiple possibilities that were available in the superposition. Continuing from the previous video, more complex than carbon or oxygen, silicon is an atom with more electron shells around its 14 protons, plus, in its nucleus. To stay together, all of these electrons, protons and other energy forms must get connected to be quantized. When multiple silicon atoms are arranged in different arrays, each pair of silicon atoms has many superposition states. As shown in prior video, many bonding and no bonding state networks like rhizome can be possible. Medium-sized atoms, such as silicon, have a moderately narrow energy difference between bonded and unbonded, electron in motion, states. It's not scientific or philosophical, but metaphorically, you can think of it this way. A person with limited experience and thinking is likely to be rather extreme, but a mature person with many mental entities to connect to when drawing conclusions will show an easy transition from one opinion to another because of the possibility of numerous connections. The odds may be higher. This makes semiconductor atoms like silicon useful for controlling the flow of electron energy waves. In addition, the principle that carbon nanotubes, even simple carbons connected countless times, show similar interesting properties, was presented to mankind as a gift. Carbon atoms originally have a large energy gap between their bonded and unbonded states, so electrons are trapped in the bonded state, making it an insulator and giving no opportunity for electrons to move. However, in a certain ways of networking like rhizome, it can become semi or good conductor. This is because with more connections, the difference between bond and no bond is not so great that electrons can easily move from bond to non-bond, move. Electrons can easily be pushed away by doping, mixing atoms with relatively free electrons, such as nitrogen or phosphorus, to create the silicon network's electron push desire. Also, by incorporating atoms such as boron into silicon, it creates a desire to attract electrons in the same network. Electronic states in the bonded state, not moving, are considered 0, and unbonded states, higher energy, donating and moving electrons, that enable flow and fluidic connections are considered 1. When an electron is placed on a non-bonding energy wave, it starts to flow from a high potential energy region, phosphorus-doped silicon region, to a lower energy region, boron-doped region, just as water flows downward due to gravity. The energy difference induced the flow of electromagnetic waves. An array of microchips, or well-crafted connections, can create combinations of zeros and ones in bytes and streams of useful energy. The bytes can be a code for a certain meaning to human. First of all, it can be used to remember certain things like sound, picture, or words by having electron in a certain state for 0 or 1. A memory chip with a floating gate is a type of non-volatile memory that keeps electrons in a particular state, which means that it can retain its stored information even when it's not powered on. When a voltage, moving electrons that are pushed, is applied to the gate, electrons can flow into the gate and become trapped in the structure of electron-accepting atoms, such as boron, in an insulating material, creating a negative charge, repulsive field. To store information in the memory chip, a process called programming is used. Programming involves applying a high voltage to the gate, which causes electrons to flow into it and become trapped. The amount of charge that's trapped determines whether a 1 or 0 is stored in that location. To read the information from the memory chip, a process called reading is used. Reading involves applying a lower voltage to the gate, which allows a small amount of current to flow through the transistor. By measuring the amount of current that flows via electric force measurement, the memory chip can determine whether a 1 or 0 is stored in that location. This charge can be passed through sensors that energize tens of millions of gates and circuits programmed to add up the electromagnetic forces generated internally in a specific way, and measure the resulting current, the output electromagnetic energy. And gates work by taking two or more binary, 0 or 1, inputs as either electromagnetic force or any energy value and thus producing a single binary output, 1 or false, value only when both values are satisfied. In addition to memory, processors, such as CPUs or GPUs, use internal circuitry, usually based on transistors, to control the flow of electricity based on input signals. The inputs, A and B, are connected to the AND gate, and the output, C, is created as a linkage of electromagnetic forces by the gate's internal circuitry, such as the rhizome or the connections of the brain synapse network. Like an a priori, the circuitry of an AND gate or other logic gate usually includes a transistor that acts like a switch that can allow or block electricity flow depending on an input signal. The internal circuitry of the logic gate allows current to flow to the output, C, by chemically synthesizing the doped material, atoms and silicon materials, and scientifically adjusting the connection between them, to a specific energy state and the combined shape of the wave pattern. Generate the voltage and current of the corresponding information. Artificial neurons in AND connect stored information and new inputs to make simple decisions with various sensors, controllers, and processors. Based on the principle of mathematically changing their combination method, new, evolved information is created as a state function. Let's continue on the next one. See you next week.